Okay, so last time we talked about random sampling and simple random sampling. If you're sampling randomly, every individual in the population has the same chance of being chosen for the sample. If it's a simple random sample, you're just simply taking your sample altogether randomly. If you apply some other process, it's not simple random sampling anymore, but it could still be random. So here are the first three here are types of random sampling that you can do that are not simple, but it may serve your purposes just as well. So the first one's called stratified. The stratified sample is like the previous example where we split the population into male and female, and we took a random sample of 500 males and a random sample of 500 females. So stratified is when you divide your population into groups, and you take a simple random sample of each group, and you put those together to make your sample, your sample as a whole. Now that whole sample won't be simple random, but it'll still be random. Okay. Sure. That work? Okay. So stratified, you divide into groups, you sample from every group. Systematic, you select a random starting point. I guess that should say that here. You should select a random starting point It needs to be a random starting point less than k, and then you select every kth element in the population. So if you remember the phone book example, right? If I asked you to, call random numbers out of the phone book, one way you could do it is say, let's pick a random number from 1 to 10, and then we'll pick every 10th number in the phone book after that. Okay. It's just a systematic way of getting your sample that way, and it will be, spread out across the whole phone book. Is it random? It's random because you pick that starting point randomly. So before you pick that starting point, every number in that phone book has the same chance of being picked. But once you pick that starting point, they're all picked, automatically. Okay. So you would pick, say we chose 7, then we would pick the 7th number and the 17th number and the 27th number and the 37th number, on and on. Okay. So that's called systematic. All right. The third one's called cluster. Cluster is very similar to stratified, and it's very confusing for some students, so make sure you know the difference. A cluster sample is when you divide the population into groups, and you take a sample of the groups. So you don't choose every group, but once you pick the groups, then you survey every individual, or you collect data from every individual in those groups. So a stratified sample is when you split into groups and you sample from every group. You just sample, but you do it from every group. A cluster sample is you don't pick all the groups. You pick a sampling of the groups, but you survey every individual in those groups. So we could do a study on gas prices in Tennessee, and we could divide up our gas stations into the counties. Right? We could make the counties our groups. If it was stratified, we would go to 5 gas stations, 5 randomly chosen gas stations in each county, and record the gas prices. But if it's a cluster sample, we're going to say we can't go to every county. Let's pick 5 random counties in Tennessee, and then we'll go find every single gas station in those counties and record the gas prices. So that's a cluster sample. Everybody okay with that? We're going to do some examples where we see which one's which. Those are all random, but they're not simple random. Okay, those three are random, but not simple random. We've applied an extra step, an extra process. Okay. Next one is convenience. So a convenience sample is just simply using results that are easy to get. So if I were to give you an assignment where I said you need to survey 25 random people in the Chattanooga area, and it's due by Friday, what are you going to do to get those 25 surveys done? Yeah, you're going to survey your classmates. You're going to survey your family members, right? You're going to survey your friends, your coworkers, right? You're going to take what's available at hand quickly, right? So do you think that group, that sample of the people around you, you think it's representative of the whole Chattanooga area? Probably not. So, convenience samples, whatever conclusions you draw, whatever kind of statistics you calculate, it's only good for the sample that you took. You can't infer it to the population. You can't extend those results to the population because this sample is probably not representative, okay, of the population. So convenience samples are not considered very good. Sometimes it's the best you can do, but you wouldn't write a paper and publish it if you took a convenience sample. Okay. If you see a poll on ESPN or CNN, let's say ESPN. If you see a poll on ESPN's website, that poll might be useful for ESPN, and it might be useful for the customers of ESPN, but who is clicking on the survey and taking the survey? It's the people who go to ESPN's website, right? And that may not be a representative sample of everybody. Not everybody goes to ESPN's website. Does that make sense? So it may be just perfectly fine for them to use, but they're not going to write a research paper based on that survey because it's not rigorous enough, right? All right, sample size considerations. Later on in the semester, we will need to calculate how big a sample we need to take prior to taking the sample. If you take a sample and you compute statistics and you want to extend it to the population, we have to calculate that margin of error. Right? From our first lecture, that margin of error in that problem, that's something we can calculate. And we might want to make sure that that margin of error is small. In order to do that, we'll have to kind of reverse engineer and say, well, what type of, or how big of a sample do we need to take in order for that margin of error to be small? So, if you calculate the margin of error and it's like 15%, maybe it's not good enough, so you want to avoid that problem. You want to make sure that your margin of error is 5% or less, or even, you might try to do better than 5%. So that's something that we will calculate later in the class, okay? Any questions? So we're going to do some examples. So I should say simple random. Let's just say simple random. Determine whether the sampling that they used was simple random, systematic, convenience, stratified, or cluster. Okay. So simple random, systematic, convenience, stratified, or cluster. So number one, in a study of college programs, 820 students are randomly selected from those majoring in communications. 1,463 students are randomly selected from those majoring in business. And 760 students are randomly selected from those majoring in history. So is this, which one is this? Is this stratified? That's correct, stratified. So it's stratified because they're randomly sampling from those groups. So we're going to have to assume that their population is all students majoring in communications, business, and history. Okay, and they divided them up by major, and they sampled from each major. That's how they got their data set. So this one is stratified. On the day of the last presidential election, ABC News organized an exit poll in which specific polling stations were randomly selected, and all voters were surveyed as they left the premises. So the population is all voters, right? All voters. Did they divide them up in any way? Yeah, they did. So where each person voted groups the voters at that polling station. Does that make sense? So the voters are split by where they voted at their polling station. Could they go out to every polling station in the United States? No. So instead, they chose, they randomly chose some polling stations. So specific polling stations were randomly selected. So they just chose a few polling stations, and then they surveyed every voter as they left. So that's cluster. Yeah, so this is a cluster sample. It's still random because they randomly selected the polling stations, but it's not simple random because they applied this process of splitting these into groups and picking groups and then surveying all in those groups. That one's hard to distinguish between stratified. Okay. At a police sobriety checkpoint, every fifth driver was stopped and interviewed. Systematic. That's going to be the easiest one for you to recognize. Systematic. In a Gallup poll, 1,003 adults were called after their telephone numbers were randomly generated by a computer. 20% of them said that they got their news from the internet every day. We're going to assume that the numbers generated by the computer were random. That's not one of our choices, right? It's either stratified, cluster, systematic, convenience, or just simple random. They just simply randomly got these. It's simple random, right? They picked 1,003 adults to call. They just randomly got them with a computer program. They didn't apply any other process to it, right? So this is just simple random. Stop me if you disagree or want to talk about it or have a question. Literary Digest magazine mailed 10 million sample ballots to potential voters, and 2.3 million responses were received. Convenience. Yeah. So, this is the equivalence to you asking your friends and family, right, to take the survey. They just took the mailing list of their customers that they send their magazines to, and they sent them a ballot. Right? So, would this be a representative sample? There's a lot in the sample, right? It's a big sample. So given that the sample is so large, Was it reasonable to expect that the sample would be representative? I agree. No. Why? It's just their subscribers, right? That might not be representative of everyone. And also, not everybody responded, right? So the people who responded and mailed the thing back might be different than the people who did not, who just threw it away, right? Or paid no attention or ignored it, right? So, we'll say the people who responded to the ballot may differ from those who did not. And we could also say people who subscribe to Reader's Digest may be different than people who don't, right? So, I mean, there's a lot of things we could say there. Okay. I'm going to hide the results here. Maybe that won't influence you in what you pick. So this question says, students at a university are classified according to major. The administration randomly selects 5 majors. All students majoring in those 5 areas are surveyed. What type of sampling is this? I'll give you a few minutes. All right, there's 12 responses. I'm going to call that good. So 55% said stratified, and we're now 58. 42% say cluster. Cluster's catching up. So somebody who said cluster, tell me why. Why do you think it's cluster? Go ahead. Not instead of one, but instead of going to all the majors. So if they went to every major and they just sampled a few students out of every major, that would be stratified. This one is they didn't pick every major, they just picked 5. They randomly picked 5 majors. And they went to all 5 of those majors and they surveyed every student who was majoring in those 5 majors. So I told you it was confusing to tell between these two. So you got to be able to get that one right, okay? These are the subgroups.
Yeah, they split up into that. So instead of getting all the majors, they chose 5.
Right.
So wouldn't that be stratified or stratified?
In stratified, you only pick random participants out of the groups, and cluster you pick all members of that group.
In a stratified sample, every major would be the subgroups. So you would divide the whole population by major, and you would survey students in each major, all the majors. But you would only pick a few. This one is, they didn't go to every major, they just picked 5. And they surveyed every student majoring in those 5. So that's cluster. So stratified is dividing into groups and randomly, or let's say it this way, taking a simple random sample from each group, okay? Not all, not all the students in each group or not all the individuals in each group, but they do survey all the groups, okay? If it's cluster, they don't survey all the groups, they just pick a few randomly selected. But when they go to those few, they survey every individual in those groups, okay? They're very similar. So you have to be ready for that. That's going to be on the test. Any questions? So the last section in chapter 1, we're a little bit behind, but don't worry. It's okay. I thought we'd get this done last week, but we didn't. Bias and sampling. If the results of the sample are not representative of the population, then the sample has bias. So that's just a very simple definition. If you take your sample and it's not representative of the population, then it has some kind of bias. Okay. So there are different ways this can happen. First one is called sampling bias. That means the technique used to obtain the sample's individuals tends to favor one part of the population over another. Like Literary Digest favored people who subscribe to Literary Digest over another group, right? So that would be a sampling bias. So any convenience sample is going to have bias. Okay. Any convenience sample will have bias. Sampling bias also results due to undercoverage, which occurs when the proportion of one segment of the population is lower in a sample than it is in the population. So, if I was doing research on all U.S. citizens and I only used my students to get my results, then my sample will be heavily populated with 18 to 25-year-olds, right? There will be fewer less than 7. We have some less than 17 students, and we have a lot of adult students who are older than 25. But they will be less represented than the 18 to 25-year-old group, which makes up most of our students, right? So that would be, we would undercover those under 17 and under and those over 25, right? If I did it that way. And that would be another convenient sample, right, if I did that. Non-response bias. When the individuals in the sample who do not respond have different opinions than the ones who do. I would ignore these because this is old. This is not true anymore. Okay. Response rate on telephone surveys are not 70% anymore. They're way, way lower. I need to update my notes, but I haven't yet. if somebody calls me at home and asks me to take a short 15-minute survey, I'm just hanging up the phone. That's just how I do it. But if they call somebody else, if they call my grandfather, he might talk to them for an hour. Okay, so what that means is me and him are different that way. We might have different opinions based on that. So the Literary Digest survey, they sent out the ballots to 10 million people. 2.3 million people responded. What about the ones who didn't respond? They're different than the people who did. The people who took that ballot, filled it out, put it in an envelope, and mailed it back, are different than the people who just threw it away, okay, or just ignored it, right? So that's what we get by non-response bias. It's hard to avoid this when you're dealing with people. You can't make people do surveys, right? Because we live in the United States, live in a free country. Okay, I can't make you. Now I can make a survey a prerequisite for the first homework, which I did. That helps. That helps you to take that first survey in the homework. But it doesn't mean I can get everybody to do it, and I can't put anybody in jail for not doing it. Right? So it's just hard to avoid this non-response bias when you're dealing with people. The two methods of improving non-response are callbacks. So if you're telephoning, you call them back at different times to try to catch them when they're at home. And rewards for survey completion. So a lot of companies will say, if you take the survey, we'll enter you in for a chance to win a free Amazon gift card or something like that. So it gets a little bit more people to respond. It still doesn't get rid of the non-response bias. Okay, it just helps you get more people in your survey, but it doesn't necessarily get you a representative sample. If you go to a restaurant, and the restaurant will have a comment card on the table, right? How many people work in restaurants, or have in the past? A lot of you, right? So who fills out the card? People who are really upset with something, right? Or it could be they were just really, really happy with it and they had to write it down and tell somebody about it. Right? So people who fill out that comment card have strong feelings one way or the other. If they just went to dinner and everything was okay and everything was fine, nothing special, they're not filling out the card. Does that make sense? So the people who fill out the card are fundamentally different than or had a fundamentally different experience than the people who did not. Okay, but the restaurant may only be worried about those people who had bad experiences. That might be their only focus of the comment card data, is to fix problems. But that's it's not representative of the entire population of their customers. Right? All right, next is response bias. The answers on a survey do not reflect the true feelings of the respondent. So there are a lot of different ways this can happen. One that's not on here is people just lie on surveys too. Okay, if you ask for someone's weight, they are going to lie about it, almost always. Okay, just think, especially if it's not anonymous, right? If the survey is not anonymous, or if it's in person, face to face, or even on the telephone, people will lie about whatever. Okay. But other reasons are interviewer error. An experienced interviewer must make the interviewee feel comfortable enough to answer truthfully. Misrepresented answers may occur when individuals are asked to self-report. So, you just get errors when someone's taking a survey and they don't understand the question. Wording of questions. Care should be taken to created balanced questions. Avoid vague questions. So you want your questions to be balanced, and the order of the questions can matter too. That might be next. Let's just talk about the wording. How can we reword the following question to make it balanced? Do you oppose the implementation of Obamacare? How can we change it to make it balanced? Go ahead.
How do you feel about Obamacare?
How do you feel? Yep. Somebody else. The word oppose is the problem, right? So how do we fix that and make it balanced? So she just took it out, chased it with something else. So if you wanted to leave oppose in there, then how would you balance it out?
Support or oppose?
Right. So that's a good way. Do you support or oppose the implementation of Obamacare? And then that makes it more balanced. You know, if you just say oppose, then someone who maybe doesn't agree with Obamacare, but they're not actively opposing it, right? They're not marching in the streets about it. Then they may answer no when the intent of the interviewer is to just tell whether they like it or not, right? So, or they agree with it or not. So there's different ways to fix that, but this question, the way it's written, is probably not the best. It doesn't look like it's poorly written, but the answers will come back. You may not get the results that you're looking for. Okay. Yeah, the next one was ordering. So ordering of questions or words. A strategy to deal with this is to rearrange the order of the questions within a questionnaire so that responses are not affected by prior questions. So, interviewers can design a survey in which a series of questions is asked, but all they care about is the last question. And all the questions before that are leading you towards saying the correct answer, right? And if you're wanting to get certain results, then you can create those results artificially by how you order your questions in your survey, so that you get a better response at the end. If you have two questions that are related, then the order that those questions in can affect the answers to those questions. So for instance, if you asked a question like, do you like football? And you get the person thinking about football. Yeah, I like football. And the next question is, what is your favorite sport? Well, you've already got football in your mind. You might just say, more people might say football, okay, if they're unsure. Whereas, contrast that with if you ask, what's your favorite sport first? Football may be one of their favorites, but they might pick something else. And then you ask them if they like football. The responses will be different there. Just by putting something in someone's mind, then it will affect how they answer questions later on. Type of question. So there's open response questions and closed response questions. So a closed response question is like multiple choice. You have a list of options. You have to pick one of the options. Okay, that's closed response. So an advantage to closed response is that it's easier to handle the data because you only have these 5 responses that you have to deal with, and they'll already be counted up and listed there. Okay. But what's the disadvantage to a closed response question? Sorry? You don't get as many options. Somebody taking the survey may think of something that you didn't think of, and they can't choose that in the options. So you miss out on some information. Okay. An open response question would be like, what's your opinion on blank? Just let them write whatever they want to write, or make comments. There's usually a comment section on every survey. or every form. So, if they have open response, then you can collect every piece of data that your survey respondents are willing to give you, right? But what comes with that is it's very difficult to manage that data and to clean it up. You have to go through every person's response, read it, and try to categorize it in a way that you can analyze it. Okay, it's very difficult. Any questions? Are you sure? Okay. Next is errors in sampling. So non-sampling errors result in the process of obtaining the data. So this is all the stuff we just talked about. The undercoverage, non-response bias, response bias, or data entry error. Okay, those all fall into non-sampling errors. That's just going to make the results in your sample be off from the true results of the population. So what's true about the population will be wildly different than what's true about the sample. Okay. But we also have sampling errors. So sampling errors result from using a sample to estimate information about a population. These occur when the sample gives incomplete information about a population. So even if you do everything correctly and you take a random sample, you pick whatever sampling technique you want to use that's considered a good one to use. If it's random or simple random or stratified or cluster, those are okay to do. You're still picking randomly, right? There's a randomness involved. And randomly, you could pick a sample that is wildly off from the population. Okay? So sampling error can occur. That's why that question had, that research problem we talked about last time, they only had 95% confidence in the result because when they took the random sample, there's a chance that their sample, got weighted one way or the other on the respondents. Okay. Even if they did it randomly. Okay. Randomness gives you the best chance, but it doesn't always happen. Okay. Sometimes you just get results that are off. Okay. And we call that sampling error. If you calculate the sample average, it's not going to be the same as the population average, just because the two are different. You would hope that the sample average is close to the population average. Okay, and if it's close enough, you might be okay to say, well, this sample is representative, but you're not guaranteed that. And sometimes you don't even know what the population average is. A lot of times you don't know. So you're just trying to use the sample to get an idea. All right, so that is all of chapter 1. It's late in coming, but now we're ready to go to chapter 2. We actually get to do some math. So this makes me happy. Chapter 2 is all about organizing data, but we're going to focus on organizing quantitative data. So just discrete, continuous, numeric data that represent quantities. And we need to be able to organize them. And this is going to involve putting the data into a table and making a graph from the table. So having an organized way to look at the data and to get a visual representation of that data is our goal in this section. So the first one is called frequency distribution or frequency table. It's a table that we also call a distribution. We will also call graphs a distribution. So anything that shows you how the data is distributed. You know, how many 18 to 25-year-olds do I have? How many 25 to 35-year-olds do I have? How many under 18 students do I have? Anything that shows me that information, we call it a distribution. Okay. So frequency distribution or frequency table. So large sets of data need to be organized so that we can recognize trends in the data and make predictions. A frequency table partitions data into classes or groups. You know, we'll call them groups or classes. It's the same thing. And it lists how many data values are in each class. So that's the frequency part. So we define groups or classes. We count how many in our data are in each class, and we just add them up, add up the frequencies. So we just figure out how many are in each group. And no overlap is allowed among the classes. So you move from one class to the next. They're all split. There's no overlap in those classes. So we have a data set. It says the following data represent the number of customers waiting for a table at 6 p.m. for 40 consecutive Saturdays at Bobak's restaurant. Are these data quantitative or qualitative? Let's answer that one first. Is this qualitative or quantitative? These are number of customers waiting for a table. Quantitative. It's a number, and it represents the amount of something, how many people are waiting for a table. It's definitely quantitative. Are they discrete or continuous? Discrete, because you count to get the number, right? You count how many are waiting for a table. It's not a measurement. We're not measuring and rounding to the nearest whole number. Okay, we're just simply counting them. So these are quantitative and discrete. And just at this data, there's not much that we can determine from it, because it's just a jumbled set of numbers, right? So that what we want to do is make this organized so that we can see things, we can figure things out. So here is a frequency table. We've divided up our data into classes. So the classes are 2 to 3, 4 to 5, 6 to 7, 8 to 9, 10 to 11, 12 to 13, 14 to 15. There are no overlaps. There are no breaks. In terms of in this case, these are discrete. So you go from one whole number to the next, and they're all the same size. So you want each class to be the same size. So we're simply going to look at this data and count. Okay, this is not too difficult. So I'm just going to look through the data, and I'm going to count how many 2s and 3s there are. And I'll do it, and you or let me know if I mess up. Okay? Now I'm going to mark them off as I do it. So there's 1, 2, and that's it. Is that correct? All right. So the frequency of this class is 2. There's 2 of those. There were 2 Saturdays in which there were only 2 to 3 customers waiting for a table. Okay, 4 to 5. Use a different color. So I got 1, 2, 3, 4, 5, 6. Is that correct? Did I miss any? 6. 6 to 7. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that correct? 9? This is very tedious. And you can mess up. So, sorry about that. 8 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I got 12. Uh, 10 or 11, I'll circle these. So there's 1, 2, 3, 4, 5, 6, 7, 8. I got 8. And the next one is 12 to 13. 1, 2. It's got 2. And 14 to 15. It's like there's only one of those. So 14 right there. There's one. The first way to figure out if you've made a mistake is you got to get every data point in your set. Okay. Another way to check is how many were you supposed to have? 40. So if we add up all these frequencies, we have to get 40. So let's add them up. 2 plus 6 is 8. 9 is 17. 12 is 29. 37, 39, 40. So if you add these up, you do get 40. That doesn't guarantee you did it all correctly, but it's a good start. Right, just a couple definitions related to the table. A lower class limit is the smallest possible number in each class. So in this case, all of these numbers on the left are the lower class limits. Or lower, you can just do LL, lower limits. And then the other side, the largest possible numbers in each class are the upper class limits. Upper class limits. The class width, which gets some students sometimes, the class width is the difference between two consecutive lower class limits. So you find two consecutive lower class limits and you subtract them. So the class width here is 14 minus 12, which is 2. So the class limit of, or the class width of this table is 2. So what students want to do is they want to look at a class and subtract the lower class limit and the upper class limit. In this case, you would get 1. And that's not the class width. So you look at it this way, from this lower limit to this lower limit, it's 2. It's the same for the upper limits also. You know, the difference between each consecutive upper class limit is also 2. That also has to be the same. We're okay with that? What if we had 1,000 data members in our sample? You wouldn't want to go through and mark them off one at a time. Okay, so we'll use software to do this. Okay, so in a few minutes we'll open up StatCrunch in our course and we'll be able to do this automatically. Okay. All right. What is relative frequency? So instead of just a count, you're going to find the percentage that each class represents to the total. So if I have a frequency of 2, when there are only 10 members in the sample, that represents 20% of my data. Does everybody agree with that? If I've got a class frequency of 2, and there's only 10 data members, and that's 20%. If I have a frequency of 2, but there's 100 members in my sample, with sample size 100, then that 2, the same frequency as the other one, would only count for 2%, not 20%. So we want to always calculate the relative frequency. What does that frequency mean relative to the rest of the data? What percentage does it represent? So the relative frequency for each class is the class frequency divided by the sum of all the frequencies. This sum is just the sample size. And if you want that in a percentage, you have to multiply it by 100. So you don't have to put it in percentage form, but sometimes you're asked to in the homework. And I think sometimes it makes sense to do it that way. But you can just use the decimal form, and it means the same thing. If it's in a decimal form, you call that a proportion. And if it's in percentage form, you call that a percentage. So you help me out. Tell me what the frequencies were. I think it was 2, 6. What's the next one? 9, 12, 2, 1. Okay, thanks. So we'll fill out the relative frequencies and then we'll convert them to percentages. And it says to round all of them to the nearest hundredth. What does that mean, hundredth? How many decimal places is the hundredth decimal place? 2 decimal places. So we're rounding to 2 decimal places. All right, so for the first class, the frequency is 2. The sum of all the frequencies is what? 40. We added up all those frequencies and got 40, right? And that's the sample size. So that's what it means by sum of all the frequencies. Sum just means add them up. All right, so the sum of all those frequencies was 40. So this is 2 divided by 40. I need a calculator. I forgot I was doing math today. Didn't have my calculator ready. You don't have to. This emulator is on all of our computers here. So in the classrooms, our math classrooms, and in the math center. So if you don't want to buy this, you don't have to. And it's not going to be an essential part. We're going to use StatCrunch for a lot of things, and it's included in the MyLabs Plus. So you don't have to buy that. All right, so 2 divided by 40, 0.05. And we didn't have to round that. That's exact. That's the same as if you write 0.05 or 0.05. It's the same thing. The relative frequency percentage, anytime you see a percent symbol, you have to convert to percentage. So if you multiply that by 100, what do you get? You just get 5%. Right? So times 100. All that means is you move the decimal place to the left 2 places. To the right 2 places. Move your decimal place to the right 2 places. Okay? All right, 6 divided by 40. 0.15. Percentage is 15%. So a proportion of 0.5 means 15%. And then 9 divided by 40. What is that, 0.23? We round to the nearest hundredth. Right? What's the percentage? It's not 23%. What is it? 22.5%. So we're rounding the percentage to 2 decimal places. It's different than rounding the proportion to 2 decimal places because you're at a different place. Right? You're at a different decimal point there. So this would be 22.5%. So if you have to round the percentage to 2 decimal places, you have to convert it before you round. Okay? So you multiply by 100, or you move the decimal and then you round to 2 decimal places. So that's a place you can get messed up on this if you round before you convert. 12 divided by 40, 0.3. What's that in percentage? 30%.
Zero.
Sorry?
0.30.
You don't have to put the 0. Probably should, but you don't have to. Point 2, 20%. And I already know what 2 is, right? 2 is 5%. 0.05, 5%. And then 1 is 0.025. So we round that, we get 0.03. What about the percentage? 2.5%. Good. Everybody okay with how I made that table? What percentage of Saturdays had fewer than 6 customers waiting at 6 p.m.? 20%. How did we get 20? So the fewer than 6 would be these 2 classes. All we have to do is add up these percentages. It asks for percentage, so we're going to give our answer in percentage. So it's 5 plus 15, 20%. You could also add the frequencies. Divide by 40. They're the same as 8, right? You get the same answer that way. If you add the frequencies and then divide by 40. I think I have a question here. Let me see. Let's do these 2 in a row. Let's not. Let's talk about histograms before we get to this one. We can do this one. Let's do this one real quick. I had them out of order. So here's a frequency table. What's the class width? All right, let's see what's the correct answer. It's 5. So the mistake is to subtract these 2 and get 4. You want to subtract 6 and 1 or 5 and 10, right? You want to subtract consecutive limits. 6 minus 1 is 5, so the class width here is 5. Okay? So a histogram is a graph of a frequency distribution. So we just made a frequency table. So if we took that table and made it a graph, it's going to be a bar graph. It's going to be vertical. but it's a specific type of bar graph. So it's not just a bar graph. It has these other characteristics. The width of each bar is the class width. Okay, so how wide the bar is before it goes up is the class width. The height of the bar will be its frequency. Okay. There are no gaps between the bars unless you have a class with a 0 frequency. All the bars will be stuck next to each other. Horizontal scale represents classes. Vertical scale represents the frequencies. And you can make a relative frequency histogram as well. It will look exactly like the regular frequency histogram, but the scale will be different. Okay, but it'll have the same shape. It'll look almost the same. It'll just have a different scale on the y-axis. So we're going to take our frequency table, turn it into a frequency histogram. So let me see, 2, 6, 9, 12, 8, 2, 1. Is that correct? All right, so we're going to take that frequency table and just make a histogram. So notice that these are ticked off every 2 because the class width is 2. Okay? So the first class will be every number from 2 up to 4, but not 4. Does that make sense? So this doesn't go 2 to 3 and then a gap, and then 4 to 5 and then a gap. That's kind of how it is in the table, right? We jump from 3 to 4, but in the histogram we don't. We're going to go all the way up to 4, and we're going to have a frequency of 2. So we'll just draw a bar that has height 2 from 2 to 4, but the 4 is in the next class. Okay, it's not in the first class. And then 6. You bump these right up against each other like that. 9. That's supposed to be halfway between 8 and 10. I'm not very good at drawing with these pens especially. 12. 8. 2. And 1. And sometimes you'll actually, write the frequency above each bar. You don't have to do that. But it's kind of nice to do that. So we would also call this a distribution because it gives us the same information. We see how the data is distributed amongst our classes. It's just one is a distribution in a graphical form, and the other is a distribution in the table form. But they both tell you the same thing. We see kind of a symmetry going on, right? Where most of our data is in the middle here, and then it drops off on the outside in either direction. So there's a symmetry that you can see. It's not perfect. It's not a perfect symmetry, but you can see a symmetry there, and that's going to be important as we go forward, right? We want to know what shape does this histogram have. Okay. So most of the time, right, we're going to have between 6 and 12 customers waiting for a table. That's what's in the middle. We would expect our average to be about, in that range. We would expect the average to be right around 9 or 10. Any questions about histograms? Okay. Let's do this question. Then we'll call it a day. Thursday we will finish this section. We'll move on to the next one, and we're going to do stuff with StatCrunch. So we'll be able to actually, work some problems, not just answer questions about definitions. So which one on the graph has the highest frequency? This one, right? So it can't be A. So which one is it, 18 to 22 or 18 to 23? It's 18 to 22 because remember this 23 starts the next class, right? It's not in the first class. The right endpoint moves on to the next class. The left endpoint matters, not the right one. All right, have a good one. Yes.